plan is to discuss the creation of this particular mechanism that you see here. These are kind of side by side identical, except that in one case these arms are arcs of a circle, and in the other case these are straight line. Since there's a great deal of similarity between the two, I will only discuss the one on the right, which is a bit more involved. So I'm going to close this for now, and let's start with this. Here's the situation. We have 4 parts. This is the base. Here is the big arm. Here is the small arm, and there's a wheel. And the wheel rolls on this track. Okay. Just to show you the kind of mechanism that this this is dealing with, let me move these around. So let me do a rotation about this particular axis, free rotation. So as the wheel rolls, this orange arm retracts into the green arm, and so basically we have a revolute joint here, a revolute joint there, a roll curve joint between the wheel and the track. Now there will be some issues when we try to model the joint associated with the small arm or the orange arm and the green arm, and I don't want to give up the issues or discuss the issues that we're going to run into right now. So I'm going to close this, start with an assembly, and then create the joints as we anticipate. So let me close this. All right. Let's just wait for this thing to disappear. I'm going to start a new product file and bring in all the 4 parts in it, and will not be using the magic wand either, so create all the joints manually myself. Okay, so close this, don't save anything. Let me start with the product file. And insert the existing components, and the components are coming from that particular folder that I mentioned. So yep, so it's going to be the base, the arm, control, the extender, the ground, which is the base. No, actually, let me go back and get the correct folder. So it's going to be right there, curved arm. So it's going to be the base, the big arm, the small arm, and the wheel. Of course, I'm not going to be using this. This is the product that I showed you. So we're going to do everything from scratch. Good. Okay, all of them are here. So first of all, let me hide the sketch here for you. All right. Okay, let's first fix the base. Okay, this is the base. This is the base. So I'm going to fix it, anchor it. All right. We don't have to do that because you're not trying to use the magic wand. So let's actually go ahead and yeah, let's go ahead to digital mockup, DMU kinematics. Let's create our mechanism, fix part. Okay. The anchor that I used earlier was in assembly design. I'm not using the magic wand, so that will not be participating in our calculations. So that's why I'm fixing the arm here again, or the base here. A new mechanism, and anchor the base. Good. And by the way, I think I made the color of this yellow. That's really, oops. Where is this? the base, the entire base. I made it yellow. There we are. Okay, let's place this this arm. This is the big arm, which incidentally I had it, I believe, as green. Okay, so we're going to create a revolute joint between this pin and that hole. So revolute joint between the axis of the pin here and the axis of the hole there, and the plane of the base right there, and the back plane of this guy. You say okay. Alright, and there we are. Okay, let me rotate this thing a little bit. So I'm going to use the compass. Okay, and update. Maybe I have to do the update from assembly design. Update. There we are. Okay. Back to DMU. Back to digital markup. Okay, now let's place the, where's this other guy? This guy. Let me move it in this direction. Okay, place this thing there. Okay, so I'm going to change the color of that to orange as it was. Okay, this is going to go inside of that track. So now, well, first let me try to make a slider joint between this edge. See that? The edge of the green one, and this edge, which is the edge of the orange one. Okay, now to do that, well, first of all, to create any one of these point joint, point curve joint, slide curve joint, roll curve joint, in order to make those joints, they must be touching to begin with. So let me go in assembly design, and first of all, make sure put assembly constraints there so that it mates them. So where is that? The assembly design. So we want coincidence between, how about this? Well, let's see now. How about the bottom surface of this and the bottom surface of that, and update. Okay, and then I'm going to make a coincidence between this I want to make this surface touch the other surface, but that's not going to be possible through this coincidence. We have to do it with contact between that face and that face. Let's update it. There we are. Okay. Now I'm going to delete these constraints because the joints I decided to use manually. So this is just to place them. Let me rotate or move this this piece. Let me move it, or let's say rotate it about that axis. Free rotation about this axis. See that? Okay. Now these joints that I created here, all of them, I'm going to delete. I'm going to delete all of these. This one, delete, because I'm creating those joints manually. Delete, delete, and this is also going to be gone. Delete. Okay. All right. Now, all right. So let's go to the digital markup, DMU kinematic, and create a, well, it sure sounds like, or it feels like, for example, this edge, you see this edge? The edge of this orange part is sliding on the edge of the screen part. So let's actually go ahead and do that. So here's slide curve. So slide curve this edge of the orange one along the edge of the green one. In order for us to be able to create this joint, the two curves must be touching, and we went to assembly design and assembled it to make sure that actually happens. All right, let's place in the wheel here. I think our wheel is, where was our wheel? Right there. There is the wheel. All right there. I'm going to make that blue. That's the color that it was. And now coincidence between the axis of this disc with the axis of that hole and the plane of this with the plane of the orange arm. Okay, there we are. Oops, it's on the wrong side though. Okay, so let me see, double click on this. I want it to be on the other side, so let me cancel that. Let me go to this, alright, this Revolute Joint. I should have said, let me double click on this, flip the arrows, maybe that will solve my problem, and update. If not, I'm going to delete it and do it again. Assembly design. Yeah, good. That's better. Okay, good. Now, the next thing is to create a roll curve joint between this arc and that edge. But in order for us to be able to do that, that arc must be tangent to this arc in the first place. This edge on the first place. So the way I have to bring this wheel and put it on that track. So I have to use contact between that surface and this surface. And if internal doesn't work, make it external. Let's try internal first. Update. Obviously that doesn't work. Where's that last constraint? Over here. We change it to external. There we are. Okay. So look, we have a Revolute down here, a Revolute up there, a slide curve joint. This edge, the edge of this orange part slides along the edge of the screen part. And what else do we want here? Oh, now I create the roll curve. The roll curve I haven't created, so I've got to go to digital markup, DMU kinematics. Here's the roll curve, you can see that. So I want the curve here and the curve there, and we say OK. This is where our problems kind of starts in the following sense. Notice that degree of freedom is 2. Now I know that this roll curve that I created, I can make it length driven, so it's going to go this way, no problem. That brings down the degree of freedom to 1. Now, this slide curve doesn't have any joint, command associated with it. And if you take any one of these, for example, if I make this thing angle driven, notice that it says that, well, it says the mechanism can be simulated, but see, let's see what you've got here. This doesn't join because basically it looks like it's all locked up. Okay? This is not going to help me. Let me take this thing out. Let me try the other one. This roll curve, a Revolute curve, angle driven. Again, it says mechanism can be simulated, but Well, although it's 2 degrees of freedom, but you see nothing happens. Okay, nothing. Reset. So the question is, how are we going to solve this? My experience was that with this problem, this slide curve is not going to do the job. So I'm going to delete this. I'm going to delete this slide curve. And what I do instead, I'm going to make a point curve joint between this curve, the green curve, and that point. So let's do it. Point curve between this top green curve and the point over. If we can't pick it, let me try to hide this and pick that point. Okay. Now what it's saying is that, look, the distance between these guys, there is a distance between them, and therefore I cannot make a point curve joint. So we say, okay, how do we fix this thing? It looks like these are not quite touching. I mean, and if you can see that, you see this? So I have to make sure that these actually are touching correctly, and they are not. So let me see, one way to fix it is go to assembly design, okay, and create a contact. Well, let me see, there may be several different ways of doing it. For example, can I make a coincidence between this curve and the other curve? Let's try that. So we have coincidence between this curve. Well, it won't take that curve, so let's see now. Let's try contact between this face. I'm going to hide this, and that face. And let's see if we have to choose internal or external. So let me bring this thing in the front. Okay, and update. I think it changed it a little bit now. See? So when I was moving these things around, try to move it around, a gap, these kind of penetrated each other. That's why I was unable to create that point curve joint that I wanted to. So let's go back to DMU kinematic. Okay, let's try it now. The point curve joint between this curve and that point. Now if I cannot pick the point, let me hide this and now try to pick it from here. You see, it was not working before, but now it is. Now let's see what happened here. So we have a degree of freedom equal to 0, but does it actually work? So let's see. What do we have here? So the first one, this roll curve one, we made it length driven. I'm going to change this Revolute. This Revolute is does not have a command. This one had angle driven. I'm going to delete this. Okay, and I'm going to make this point curve one length driven. So right now, what you've got is the roll curve one up there is length driven, and the point curve one down here is also length driven. So let's see what we can do. Obviously, there are two sliding bars. One of them is for the rolling action. Let me reset it. Immediate. Okay. You see this? However, because these are two independent degrees of freedom, notice that the orange one is not actually tracting along the green one. Okay, so we reset this thing, and this is for the point curve one that I created. Okay, reset. And the way to fix this is to create another point curve joint. By the way, look at this. These are not touching anymore, okay? So I will have to go to assembly design and update so that they actually touch right there. Okay. So what I'm going to do is create another roll curve, point curve between the curve here and that point. Let's try it. So go back to digital mockup. another point curve, this time between this curve and the point there. Okay, mechanism can be simulated. Let's try if see these things are retracting along each other properly. This is not going to do. This is not going to do. So reset and okay. So this point curve did not work. Let me try to do another one. Now notice that I have created already a point here in this orange part, which is the smaller r. I have already created a point right here, right there. So let me try this point along that same curve. We already have one about that vertex of that orange one along that green line. Now let's try this point that I've created along the green edge. So okay, let's try it. Point curve. There is the green edge, and there is the point that I have created in the orange piece. And we say okay. All right. Now let's see what happened here. How many commands do we have? It says mechanism has too many commands. Let's check it. Roll curve 1. That was this fellow, length driven, no problem. Point curve 1, the one that I created initially, is also, so I don't want to define this. Now mechanism can be simulated, and let's try see whether it works or not. So it's a single degree of freedom, as you expect. You see, everything works the way it's supposed to be. So reset. Let me try making here, insert, rewind, and we can play it continuously. Okay, so in a problem like this, there are several scenarios that in principle should work, but not all of them do. Now in the case, the initial case that I showed you, where these were both straight arms, same thing is going to happen, except that I don't have to make point curve. It can be done. You can also make a prismatic joint between this green edge and the orange edge at the other side. Now I cannot do prismatic here because prismatic requires a straight edge, but here, so what we did is roll curve between the blue and the track. This is Revolute, that's Revolute obviously. First I created a point curve between the vertex of this orange piece and that green edge. That gave me 2 degrees of freedom. So then I created another point curve between the point up here in the orange part and the edge that I had at the green part. When I created this, I did this point curve with a different set of point and edges. It did not work. Okay. Yeah. So sometimes what seems to be reasonable, unfortunately, it does not work. Okay. Good luck.